Good morning, Townview. Welcome back to Chemistry Online.
And today we'll be talking about ionic bonding and nomenclature. So top of your journal, let's go ahead and write it out. Ionic bonding and nomenclature. So a lot of the slides that you're about to see are slides you've seen before. This is all material you need to know to do well with nomenclature. So first of all, pure substances. Two things fall under the category of pure substances. The first one is going to be elements. Can anyone tell me what an element is? Go ahead, what is it? All right, so that's an example of an element. Where can we find the elements? All right, so they're all on the periodic table. Can anyone tell me what an element is, though?
It's a pure substance.
Okay, so it's made of one type of atom. One type of atom. So what type of atom is gold made of? It's made of gold atoms. What type of atom is carbon made of? Carbon atoms. What type of atom is oxygen made of? Oxygen atoms. So an element is made of one type of atom. A compound is going to be made from atoms that are chemically bonded together. It's going to be two or more elements that are chemically bonded to each other. Examples of this are going to be sodium chloride, so NaCl, H2O is another example, CO2. All of these are examples of compounds. These two right here we'll discuss later on. We typically refer to these as molecules. However, they do classify as compounds as well. Okay, so what is chemical bonding? A chemical bond is formed when electrons are either shared or given. So if you look over here at this image, or at this GIF right here, what is the red atom doing? All right, so it's giving its electron to the blue one. What's happening down here? Is either one giving its electrons away? No. So this is what sharing is going to look like. This is what giving an electron away is going to look like. So we're going to be talking more about sharing later. So today's lesson is specifically about ionic, which is this one up here. So today we're going to be talking about this type of chemical bond, not this type. So the only electrons that are involved are going to be the valence electrons. You don't need to write this. You should already know this. But the valence electrons are the only ones involved with chemical bonds. All right, so next up we got the octet rule. So what is an octet? All right, so an octet means 8, and there are exceptions to the octet rule. What are some exceptions to the octet rule? Which elements don't want 8 electrons? Okay, so the noble gases, most of them have 8 valence electrons. One of them doesn't. Which one doesn't? All right, helium. How many does helium have? Helium only has 2. So that's one of the exceptions to the octet rule. What's another one? Which element doesn't want 8 valence electrons and is perfectly content with 2? Hydrogen. What's another one? All right, so when you look at lithium, what does lithium want to be like? Does it want to be like neon or helium? Lithium wants to be like which one? Helium. It wants to be like helium, so it only wants 2. What about beryllium? It wants to be like helium. What about boron? It wants to be like helium. Carbon can go helium or neon. However, everything after carbon is going to want 8 valence electrons. So those are the only exceptions there are to the octet rule. Everything else wants 8 in its valence shell. And the reason they do this is because they all want stability. Any questions on this? Okay, let's go ahead and move on. All right, so types of chemical bonds. So we're not going to be talking about all the chemical bonds today. We're going to be focusing specifically on ionic. But I did want to show this to you. So don't write all this down. I'm going to tell you exactly what to write. So there are 2 main types of chemical bonds. There are the intramolecular bonds and then the intermolecular bonds. An intramolecular bond is going to be between the atoms in a molecule or compound. So here you have H2O. This is an H2O molecule. And here we have a bond between the oxygen and the hydrogen. This is a intramolecular bond because it's within the molecule itself. Down here, we have a bunch of different water molecules. These water molecules are attracted to each other. And the bond that you're seeing between two separate water molecules, this is called an intermolecular bond. So we're not going to be discussing intermolecular bonds today. I'm saving this for another day. And then covalent and metallic, we're also saving these for next week. So today our focus is just going to be on ionic, which is a intramolecular bond. All right, let's go ahead and move on. All right, so this is the last piece of old information. So ions, if you don't know what they are, let's go ahead and write these down. So what is an ion? In 2 words, what is an ion? It's a what? It is an atom. What is an ion? In 2 words. It is a charged... All right, it's a charged particle. So it's a particle that's charged. And it becomes charged by either gaining an electron or losing an electron. So there are 2 types of ions. We have the cations, and then we have the anions. So the cations, they got the T, which reminds you that it's positively charged, which means it lost an electron. So over here we have our neutral example. Everyone look at my screen. Here we have our neutral example. We have 4 electrons, 4 protons. Over here we have 3 electrons, 4 protons. So that's our cation. Here we have 5 electrons, 4 protons. That's our anion. Any questions on ions? Because today we're going to be talking about ionic bonding. What does ionic mean? What do y'all think? What is it? One more time. It's about ions bonding. Good. So ionic bonding is all about the bonding of ions. So if you don't know what an ion is, you're going to be really confused about ionic bonding. Let's move on. Yes.
So the cations are whenever it loses an electron?
When electrons are lost, yes. So you form ions by either gaining electrons or losing them. All right, so what is the definition of an ionic bond? Go ahead and write this. An ionic bond is formed when electrons are transferred from one to another. So over here you can see that the red thing is transferring an electron to the blue thing. So an ionic bond is forming. It's not just giving away its electron and leaving. After it gives it the electron, now these 2 things are chemically bonded to each other. And they're going to stay bonded to each other. And if they ever detach, the electron leaves, it goes back to the red thing. So that electron's not gone for good. It's just temporarily bonded. Another thing you want to know about ionic bonds is they form between ions. Form between cation plus anion. All right, so looking at the periodic table, everybody look at the periodic table with me real quick. So the metals, they all have what kind of charge, positive or negative? So they all have positive charges. What does that mean about metals? Do they lose electrons or do they gain electrons? All right, so all the metals lose electrons, which means metals are what? Metals are cations. So metals are always cations. If you look at the nonmetals, what kind of charge do they have? What does that tell us about the nonmetals? What do? They always gain electrons, which means they are what? They're anions. This creates the positive and negative attractions, and these 2 things are attracted to each other, and that's what forms bonds. You don't need to write this down. This is just the part that you know. So positive and negative, they attract each other. And you need a cation and an anion to form these bonds. All right, so ionic bonds, they typically form between a metal and a nonmetal. If it's not between a metal and a nonmetal, it's between a metal and a polyatomic ion, which we'll talk about later. The important thing to know about ionic compounds, though, is they always contain a metal. So on your paper, you want to write metal plus nonmetal. So in order for an ionic bond, in order for you to identify that it's an ionic bond, It has to have a metal in it. Another name we give to ionic compounds is salts. So if there's a metal, then it's going to be a salt. Overall, the charge of your ionic compound needs to be 0. You're aiming for a neutral charge, which means you want to have a charge of 0, which we'll talk about on the next slide. All right, last thing I'm gonna have you guys write down from this slide is formula unit. This is a term that I've seen on exams, and it really confuses students. I don't want y'all to be confused by it. So a formula unit is it just tells you the ratio of ions in an ionic compound. So has anyone ever seen salt up close? What does salt look like up close? All right, it is a crystalline structure. What kind of shape do they usually have though? All right, so they're squarish or cuboid. So they're cuboid in shape if you look at them up close. If you hit them with a hammer, they just become smaller cuboids. And basically, you don't just have one sodium bonded to one chlorine. What you have is this lattice structure. And this lattice structure we can call Na12Cl12. So here you have a bunch of sodiums bonded to a bunch of chlorines. However, we never use this as our formula. Our formula is always going to be reduced. So this would be the correct formula, even though they're always found in this crystalline structure. So what is a formula unit? A formula unit is just the reduced formula, which is the only formula that we use. We never use this. This is always wrong. And you'll see what I'm talking about in a minute. I'm going to give you all a few. All right, so let me show y'all some examples of not salts. So can anyone tell me what this is? All right, so carbon dioxide. Is it a salt? Why not? Why is it not a salt? It doesn't have a what? It doesn't have a metal. Here's another one. Is this a salt? What about this one? No. So salts they're always gonna have a metal in them. So it's gonna have a metal, it's gonna have a non-metal. That's a salt. All right, let's move on. So now we're gonna get into the nomenclature. This is the fun stuff. This is the naming. So I need y'all to pay attention. I want y'all to wake up. If you're half asleep, wake up. Now's the time. All right, can anyone tell me what an oxidation number is? What is an oxidation number? We've been talking about them for a long time. We're finally about to use them. What is an oxidation number? All right, maybe y'all can answer this. What's the oxidation number for group 1? All right, it is +1. Good. So oxidation number is just another term used to describe the charge. So I'll be calling it the charge, but just know oxidation number is the charge. So group 2 has what oxidation number? What about group 13? What about group 17? -1, and then group 18? That's 0. So those are your charges. Anytime you look at my board, you should see them. So they're not something that you got to figure out. They're just there for you. Let's go ahead and move on. So here's some practice. Lithium. What's the charge? All right, it's +1. So anytime it's +1, you just put a plus. We assume that it's a 1. What about beryllium? All right, so we're going to put 2+. So the number always goes before the charge. What about aluminum? All right, 3+ sodium. All right, +1. What about fluorine? -1 chlorine. Iodine. Calcium. All right, +2, and that's it. So this is charges. We're not going to spend too much time on it. Super easy. So we just talked about how ions are written. Our last piece of vocabulary before we start the nomenclature is polyatomic ion. Can anyone tell me what poly means? All right, so poly means many. What does atomic mean? What is atomic? All right, so it's related to atoms. And what is an ion? It's a charged particle. So polyatomic ion, its definition is in its name. So you have many atoms that are bonded together, but they still contain a charge. Let me show you all some examples of this. So I'm going to give you all a second to write out the definition. All right, so let's take a look at this. All right, so let's do H2O. So what's the charge on hydrogen? It's got a charge of +1. What's the charge on oxygen? -2. We have 2 hydrogens, so what's the total positive charge? +2. So what's our net charge? 0. It's got a net charge of 0. What if we had OH? OH? So what's the charge on oxygen? What's the charge on hydrogen? So what's the net charge here? It's going to be -1. So the formula for OH is going to be OH minus. We have to include the charge. So this is an example of a polyatomic ion. So everybody grab your periodic table real quick. Grab your periodic table. Hold it up high. All right, so find the section labeled polyatomic ions. It looks just like this right here. So the polyatomic ions section. Look at it. Everybody look at it together. Do you all see hydroxide? All right, so OH minus, it's got a name. Its name is hydroxide, and its name is always hydroxide. So this is your polyatomic ion list. You're never going to be given a polyatomic ion that's not on this list. There are hundreds or thousands more polyatomic ions. These are the only ones you're going to work with. So don't think that these are the only ones. What do they all have in common? What do they all have? All right, so they all have a charge. What is the majority charge? They're mostly negative. There's one exception. What's the exception? Ammonium, which is NH4 plus. So what is the plus? What is this? That's the charge, right? What is this telling us? It's telling us how many hydrogens there are. So NH4, that means you have a nitrogen in the middle, and it's going to be bonded to 4 hydrogens. And what kind of charge does it have? It's got a positive charge. It's got a +1 charge. The reason is because nitrogen has a -3 charge, and all these hydrogens each have a +1 charge, so the net charge is going to be +1. All the other polyatomic ions that you guys have are going to have a minus charge. That's going to matter when it comes to naming, because negative charged things are always going to be at the end. You'll see what I'm talking about in a minute. All right, so let's keep going. So you don't need to write any of this, but we're going to start with binary ionic compounds. What does binary mean? It means 2. We're going to start with things that are just 2 elements bonded together. Okay, so I'm going to help you out with the first one, and then the rest I'm going to let you guys do on your own. Actually, we're just going to start. I want y'all to practice from the first one. Okay, so at your desks, what you guys just did was you grabbed an oxygen, and your oxygen basically looks like that. And then sodium has a charge of +1, which means each sodium can bond to one part of the oxygen. So after one sodium bonds to the oxygen, is the oxygen happy? No, it's still got a negative charge. So what's going to happen? Another sodium is going to come over here and bond to it. So our goal is to have a net charge of 0. So to have a net charge of 0, how many sodiums do I need? 2. So I put a 2 here. That's going to give us a total positive charge of +2. That gives us our net charge of 0. So our chemical formula is going to be Na2O. All right? Let's go ahead and get the next one. All right, so the next one is going to be just like the one before it. So we have a +2 charge, and chlorine has a -1 charge, which means we're going to need 2 chlorines to give us the -2 charge that we need. That gives us our net charge of 0. So correct formula for number 2 is going to be CaCl2. The next one, this is the trickiest type that you're going to see, but it's actually pretty simple. So you have an aluminum, and this is what aluminum looks like for you guys. And an oxygen is going to come in and bond to it. Is the aluminum happy? Why not? Because it still has a charge. So then another oxygen is going to come in and bond to that. Now, is this oxygen happy? Why not? Because it still has a charge. So then another aluminum comes in, bonds to this. Now, is this aluminum happy? No. So what's going to happen? Then you get another oxygen, and now we have a net charge of 0. So we have a total positive charge of 6, a total negative charge of 6, which is what we were looking for. So basically we have 2 aluminums. That gives us a plus 6 charge. And then we have 3 oxygens. That gives us a minus 6 charge, which equals the net charge of 0. So correct formula for 3 is going to be Al2O3. Go ahead, move to the next one. All right, so let's go ahead and take a look at number 4. So number 4, we have 1 calcium with a plus 2 charge. Oxygen has a minus 2 charge. So how many of each one do we need? So it's just going to be CaO. Next one is hydrogen and PO4. Here we have a minus 3 charge. So how many hydrogens will we need? 3. So the formula is going to be H3PO4. And then the last one, here we have a plus 3 charge. Here we have a minus 3 charge. So how many of each do we need? Do we need 3 of each? We just need 1 of each. So the formula is going to be AlPO4. Any questions on this? Simple, right? So the point of the manipulatives is for y'all to understand what the charge actually is. It's the number of bonds that something wants to make. So y'all could go ahead and return to your seats. I'm going to show y'all another way teachers usually teach this. All right, everybody look at my screen. Look at my screen. So this is called the crisscross method. So everybody take a look. So number 1, we have sodium and we have sulfur. Sulfur has a charge of minus 2. You take the 2, you put it in front of sodium, and then you take the 1 from sodium, you put it in front of sulfur, and then we just never write the 1s. So this becomes Na2S. Was that easy? All right, so over here we have aluminum. We take the 3 from aluminum, we put it in front of chlorine. The 1 from chlorine, put it in front of aluminum. That gives us AlCl3. Easy, right? Last one, so this is the only spot where I feel like crisscross actually makes sense. It's when you have a 2 and a 3. So magnesium has a charge of plus 2, so we put the 2 in front of nitrogen. Nitrogen has a charge of minus 3, so we put it in front of magnesium. And this gives us Mg3N2. So this example is just like number 3, where you had to use 2 aluminums with the plus 3 charge. So the goal is to create a total charge of plus 6 on this side, minus 6 on this side to give us the net charge of 0. Any questions on crisscross? Do y'all want to see why I don't teach this one first? All right, so let's say you had something like calcium and oxygen. Calcium is plus 2, oxygen is minus 2. If you crisscross these, what's the answer going to give you? It's going to give you Ca2O2. Guess what answer choice A is going to be? It's going to be Ca2O2. And this is a wrong answer. So this is the only issue that I find with the crisscross method. When you have the same number, you'll make a mistake there. However, if you understand the math and you know that your goal is just to have a net charge of 0, you'll be able to answer all these questions correctly. Any questions? Are we good? All right, let's go ahead and do some practice. Actually, we're going to name ionic compounds now. So there are 3 rules to naming ionic compounds. The first one you want to remember, and I want y'all to write these down. So the first one is that the cation or the metal always goes first. The anion is going to go second. All right, second thing is we never change the name of the metal. So the name of the metal always stays the same. Calcium is calcium. Magnesium is magnesium. So I guess the rule should be don't rename metals. And the last part is going to be name the nonmetal. And the way we do that is we take the root of the nonmetal and we add an IDE to it. So the nonmetals, they're the only thing that we change, the only thing that gets a name change. I'm going to give you all a second to write these out, and then we'll talk about them. Okay, so do we rename the metals? No, we don't. So all the metals, they're going to keep their names all the time. The nonmetals are the only ones that we're going to rename. So let's practice these name changes. Fluorine becomes what? Fluoride. Chlorine becomes what? Chloride. I want more people talking to me. Bromine becomes what? Bromide. Oxygen becomes what? All right, I'm pointing. I'm pointing at iodine. Iodine. Iodine becomes what? Iodide. Oxygen becomes what? All right, oxide is correct. Oxygenide is incorrect. All right, sulfur becomes what? Sulfide. Selenium becomes what? It becomes selenide. Nitrogen becomes what? Nitride. Phosphorus becomes what? Phosphide is correct. Carbon becomes what? Carbide. All right, let's try that one more time. I want y'all to make sure. I want you to make sure you're doing these with me. So fluorine is what? Chlorine. Bromine. Iodine. Oxygen. Oxide. Sulfur. Selenium. Nitrogen. Nitride. Phosphorus. Carbon. All right, 1 second. Let me pause this. All right, so let's go ahead and do some practice. So the first one, I'm gonna help y'all out. Sodium chloride. Okay. Next two, I want y'all to do on your own. I'm gonna do 2 laps, and then we're gonna go over them. Okay, so the first one, Zn is what? All right, I couldn't understand that over the on. Zn is what? And then I is what? All right, so zinc iodide. What's the next one? Aluminum oxide. Good. Let's go ahead and do some more practice. I'm going to give you guys 4 laps, and then we're going to go over these. So these, I'm going to be calling on y'all. All right, so magnesium oxide, potassium phosphide, cesium chloride, and barium nitride. Let's go ahead and move on to writing out chemical formulas. So this time I give you the name, and I want you to write the formula. So we know that lithium is Li. We know oxygen is O. Is that it? Is this my formula? Why? What's wrong with this? What's wrong with it? What's missing? All right, charges are missing. So what's the charge on lithium? All right, and then oxygen? So how many lithium do I need for every oxygen? 2. So correct formula is Li2O. So when you're going from name to formula, plug in your charges, and then you can just crisscross the charges. Like, it's that simple.
So like, mister, just as long as the number is the same, you don't have opposite numbers, if it's not -2 and -2, then
That won't, so that's covalent. We're not there yet. Lithium, with ionic, you're always going to have a positive and a negative. All right, let's keep going. All right, so I'm going to give you guys, let's do 4 laps. I want y'all to do these. All right, let's go ahead and go over these real quick. Okay, so what's the charge on sodium? What's the charge on iodine? So how many of each do I need? It's just going to be NaI. Next one, strontium bromide. What's the charge on strontium? What's the charge on bromine? So how many bromine do I need for every strontium? So this one's going to be SrBr2. Next one is aluminum nitride. What's the charge on aluminum? What's the charge on nitrogen? So how many of each do I need? So Aln. What's the charge on barium? What's the charge on sulfur? How many of each? And that's it. Hands up, you got them all right? Okay, that's like everybody, that's good. All right, we're almost done. Let's keep going. All right, let's keep going. We're almost done. So last thing we're gonna do is the ternary ionic nomenclature, which is the same as what we just did. The only thing that's being added now is the polyatomic ions. So what you need to know about polyatomic ions is we never change their name. So here we're doing the same thing we were doing before, except this time we have polyatomic ions. So let's take a look at number 1. What is this? So calcium, we write out the metal. Yeah, I misspelled that. Calcium. And then ClO2, what's that? All right, what is ClO2? All right, so when you see two things that are bonded together and still have a charge, what are they? They are they're a polyatomic ion. So look at your polyatomic ion sheet. Did y'all find ClO2? All right, so what is ClO2? Chloride, that's it. So because our polyatomic ions are mostly negatively charged, where are you usually going to find them? They're going to be at the end. They're going to be on the right side. The only one that you would see on the left side is ammonium, which is in number 2. Anyway, I'm going to help you out with number 4 as well. So number 4, everybody find ammonium on your polyatomic ion sheet. What's the charge on ammonium? The charge on ammonium. What's the charge on chloride? So chloride, it ends in IDE. That means it's chlorine. What's the charge on chlorine? So how many of each do I need? It's going to be one of each. So it's going to be NH4Cl. All right, I'm going to give you guys, let's do 3 minutes. I want you to do 2, 3, 5, and 6. All right, so let's go ahead and go through these. So what is this, NH4? It's ammonium. And then PO4? All right, phosphates. So both of these are polyatomic ions. All right, and then number 3, we have one element, and then we have a polyatomic ion. So what's K? Potassium. And then NO2? Nitrate, good. Nitrite, sorry. All right, next one is radium nitrate. So radium is a metal. What's the charge on radium? And then what's the charge on nitrate? So how many nitrates do I need? How many nitrates do I need? 2. So it's going to be Ra, and then what's the formula for nitrate? All right, so nitrate is NO3, close parentheses, and then we're going to multiply by 2 because we need 2 of them. So in math, when do you use parentheses? We use parentheses anytime we're trying to multiply an entire unit. So RaNO3 with a 2 on the outside basically means you have radium and it's attached to 2 NO3s. One's over here, one's over here. So that's what you're looking at right there. If you don't include parentheses, does this mean the same thing? Does this mean the same thing? No, it doesn't. So anytime you're multiplying a polyatomic ion, you need to put it in parentheses. If you're not multiplying a polyatomic ion, like over here, it does not need parentheses. All right, last one is sodium sulfate. What's the charge on sodium? What's the charge on sulfate? -2. So how many sodium do you need? So it's going to be Na2 and then SO4. How many of y'all got those right? Hands up if you got most of them. All but one? All right, good. All right, so that's where we're gonna stop today. And
If you don't know how to do chemistry, hit that subscribe button. Let's go!